Good morning, everyone. Everybody having a good day so far? Cool. Okay, well, this talk is searching your Elixir code, and I'm going to tell you up front that's kind of like a little bit of a misnomer because this is also about searching other text as well. But we're going to talk about searching your Elixir code pretty much. That's the main focus. Okay? My name is Onorio Catenacci. My wife told me I should probably explain my first name because everyone asked me about it. It's an Italian name. It comes from an older Latin name, Honorius. There was an Emperor Honorius. There were 3 Pope Honoriuses, and none of them were very, very remarkable. But apparently it means honor. If you put an H in front and drop off the IO on the end, you can probably see it means honor. So I am an Elixir developer for Cover My Meds out of Columbus. I'm actually up in Clarkston, Michigan. As you can see from my T-shirt, I have been at the Elixir conferences. I was the first 3, and then I missed several, and this is the first time I've been back in quite some time, so I'm really happy. Okay, so what we're going to talk about. I'm going to give you a little bit of a background on text searching, just some kind of theoretical basic stuff on text searching and what we're looking for and how we can make it work a little better for us. Then I'm going to talk about some specific tooling and give you guys some specific code. Don't worry about taking pictures. This stuff is all up on my GitHub, so you can get all of the source files. There's not very many, honestly. The slides will be up there too. I'll also demonstrate a pattern matching language, what is called a pattern expression grammar, which is kind of the new hotness these days in terms of pattern matching. And then we'll do a little wrap up, and I have some further information on the last slide, and again, this will all be up on my GitHub site, so you can see it there. Okay, so if you think about the general concept of here's the set of text we want to search. Within that set, there's the true positive. That's what we're looking for, right? And there's also the true negative, which is like, okay, this is definitely not what I'm looking for. And then false positive and false negative, which would be false positive would be like finding something that looks right but it isn't, and false negative would be like missing something that you're looking for, okay? So ideally, what we want to happen is we want to get that result in that true positive. That's what we want. And matter of fact, we want that to actually be that whole true positive set, not just part of it. We want those to overlap, basically. But what we really usually end up happening is we usually get an actual result that contains some of the true positive and some of the other 3 that we don't want. So the question when you're searching is how do I make it more into that true positive set and less of the other set? So there are a couple things we can do to improve our chances. One, we can reduce the size of the set we're searching in the first place. Okay? We can skip certain files. If I'm searching Elixir code, there is no point in me searching HTML files. Well, maybe. Sometimes it makes some sense to search HTML files, but most of the time, we're not searching HTML files, right? If I am searching Elixir code, chances are pretty good I don't want to search for my dependencies directory. Because, again, I'm looking for my source, not dependency source. So if I can exclude that dependencies directory, I'm going to save myself some trouble. I don't want to search certain file types, like I said about not searching certain files. Well, if I know CSS represents cascading style sheets, I don't want to search those. Because again, chances of me finding my symbol I want in those files is going to be pretty low. Okay? Also, we could describe our search term a little better. We can use like a wildcard search term. I don't know exactly where I'm looking for this, but I know it starts with def module, and it's got this string, and then it's got a do behind it. I can use that to help me kind of find symbols if I'm not. I should back up a second. Part of the use case for this whole searching thing is, you're working an unfamiliar data set, right, or an unfamiliar set of source. If you're working on a familiar set of source, probably won't need any of this. Although I still do, even with stuff I've worked on for quite a while, I still do have to say, oh, where is that so-and-so defined? All right, anyway. You can also describe your context. Again, if I'm looking for a function, I'm not going to find it outside of a def module, right? So if I can say it's inside of a def module, I'm increasing my chances of successfully finding whatever I'm looking for. I can make sure, if my search term is case sensitive, and in most cases it is, that I make sure I'm specifying your uppercase or lowercase. That'll help my success. And I can also try to exclude non-matching, and this is the trickiest one of them all. I don't know how many of you have maintained source code. We've got big chunks of code where somebody's commented it out and never removed it. I hate that. It's one of my pet peeves, man. It's like someone called them a very rude name, which I won't repeat, so I'll instead call them code ghost, okay? And code ghosts are an annoyance. That's why I have source control. I don't want to keep this stuff around forever, right? That's a tricky one, though. Now, another way to improve our chances is to use tools that are specialized for this kind of thing. For example, a programmer's grep or a pattern matching language. These help us to improve our chances of getting that result in that true positive set. Now, right about now, you might be thinking to yourself, okay, this is all well and good, Onorio, but I've got search built into my editor. Why wouldn't I just use the search built into my editor? And that's not an unreasonable question. What I'm talking about are tools that do a little bit more than an editor will typically do. Also, to some extent, an editor is going to be limited by, I can only search in this directory, or I can only search in, in this file or something like that, whereas these shouldn't have that limitation. But really, a lot of times, yeah, if your editor works, go ahead and use it. No apologies necessary. And some of you are going to say, well, what about like LSP, right? I click on a symbol and I right-click it and it says take me to the definition of symbol, and that's also good. That is limited, though, to code. Like I said earlier, I'm talking about code mostly, but not only code. If you want to search log files, these techniques will work on log files as well. I don't want to load up 50,000 log files to search for something. I want my search to go through log files and find me the relevant information and then show it to me without me having to look at every one of the 50,000 things, okay? All right. I am going to assume that most of you know what I mean when I say grep, but just so I don't have to feel like I'm leaving anybody behind, grep actually comes from the name, the name comes from an older Unix editor where the command to find code was, or find text was, G, which is global /RE regular expression /P print, which it was done often enough to people broke it out to its own utility. Grep takes input from the standard input, bunch of lines, and searches for matching lines, and spits them out to the output, okay? How does a programmer's grep differ? A programmer's grep has some smarts built into it. Hey, a lot of times I'm going to assume your language is case sensitive. So I'm not even going to bother to have you specify to me, hey, this is case sensitive. It will also know about file types. Like if I said, hey, I'm looking only for Elixir stuff, the programmer's grep might be smart enough to say, okay, that's .ex, that's .exs, that's EEX, that's HEEX, that's it. I'm not going to bother to search other things, okay? So again, it's not that you can't do this stuff with other tools, it's just this makes it easier to do. A little bit less work. Okay, so this is some code. As I was saying earlier, one of the things I can do to help me is ignore certain directories. Now, for me, I don't want to look in depths for my code. I don't want to look in test because that's probably not what I'm interested in, although I could see test maybe. I don't want to look in config Because definitely, like, most of the time, I'm not looking for configuration stuff. I'm looking for symbols that aren't present in configuration. And I may want to look in priv, I may not. As I say, this code is available on my GitHub, which I will share with you later. This is shell code, and I know you're thinking, why is he showing us shell code instead of Elixir code? Because shell for this particular purpose was easier to do than doing Elixir, although you could do this in Elixir. Elixir supports shell scripting really nicely. I just didn't get quite to it. You might also notice that I've got it up there as an array. That's on purpose, so that if I decide later on, hey, I do want to search priv, I could just take it right out and I run my script again and no harm done. Makes it much easier to modify than having to go through and each flag, and I'm sorry, this is the ACK, programmer's grep. Each flag to ACK has to be ignore dir and then the dir name, okay? And I don't want to have to sit there and type out ignore dir, copy paste, ignore dir, copy paste, and do that. This is easier, okay? By default, I also want to skip certain scripts. This is ACK's syntax for specifying a particular file. Is : file name. So I want to skip mix. I want to skip credo. Chances are I've got credo on my machine. I want to skip formatter, right? And that, by putting the ignore file flag on it, it says don't look in here. Okay? And then finally, ACK allows you to specify a pager to put things out to. I just specified less. That's not really important for what we're talking about, but it's just there. And the file types is the important part. That tells it, okay, for Elixir, I want you to search EX, EXS, EEX, and HEEX. ACK right now, if you say file type Elixir, it will only do EX and EXS. I don't know why they haven't added the other two yet, but it's open source, so one of these days maybe I'll do a pull request. You'll also notice on that command line, my first argument to the script is my search string, and then I use my pager. My typeset is telling it which file types I want to search in. My ignore directories is which directories to ignore, et cetera, et cetera. The no env on the very end there is telling it if I have an ACK-RC, as you may know, a lot of Unix utilities, if you put the binary name RC somewhere, it'll use that to read like environment settings. If I have an ACK-RC, just ignore it. In this case, I would do that mainly because I don't want any potential ACK-RC to screw up any of those settings I've got. Okay? So let me show you real quick what this looks like in actual use, if I can. Can everybody see that? Good. Okay. So I have on my machine, pulled down the ecto source, just to show you, here's ACK with no special settings. As you can see, I got a ton of def modules there, which is perfectly reasonable. And you notice the very last one there's mixexs. It is, isn't it? Yeah. I think that's right. Which I don't want. I don't look in mixexs most of the time. I mean, maybe I do, but in this case, it's probably not something I really want. Okay? So now let me show you what happens when I do it with my settings for, live coding. So now I've got this forward backward thing because of lets me do this forward backward. So here, if I do F, it'll go forward in my list. And I got a little nice highlighting. One of the things I want you to notice, though, is that I don't have any priv here. I don't have any test. I don't have any deps. I'm only getting stuff that is outside of that. So that's cool. Let me show you something to kind of maybe help to illustrate the point. If I do act def module, and I pipe that into wc.l counts lines of input. The minus L means lines. So I'll just show you how many lines of output I get from that. I get 678, right? So now let me try my other command. Oop. 233. See, so I've narrowed down what I'm looking at. I would still have to look through those 233 and see if I got what I wanted, but that's a lot easier to look through, 233 than 678. Okay? So, all right. So now let's talk about pattern languages. Regular expressions get a lot of, to my estimation, a lot of deserved grief, honestly. Some of you may have heard this famous quote from Jamie Zielinski. Programmer has a problem. He sorry for the sexist language, thinks to himself, I'll solve this by using a regular expression. Now he has two problems. And it's facetious, but it's not entirely, it's not a million miles from the truth. Regular expressions, to me, are like JavaScript. Everyone wants regular expressions, but nobody actually wants to write regular expressions. And I'm not bashing on regular expressions. To me, regular expressions, as they're customarily written, are kind of like assembly language. They're fast, they're great in the hands of someone who knows what to do with them, but they're really hard to read and really hard to maintain. So, this is from an academic paper that a friend shared. That is literally what it says. I'm not, I didn't embellish it or anything like that. That's the regular expression for finding PII, personally identifiable information. Can you imagine the poor developer who's got to maintain that? Like, it works, yeah, don't touch it, leave it alone. Okay, so there's a couple caveats with pattern matching in general. One, you're mostly assuming you're matching on one line. If you want to go across line boundaries, you usually got to tell a regular expression or whatever it is, hey, I'm going across line boundaries, okay? Two, your description has to be very, very, very precise. Did I say very precise? Very precise. Spaces, uppercase, lowercase, anything like that, it's got to be exact. That's part of the reason regular expressions are so hard to do. Upper and lowercase matter for matching, of course. This was related to me by a friend of mine, Dr. Jamie Jennings, who created Rosie Pattern Language, which I'm going to show you in a minute. According to her, certain regular expressions, if you're not careful, the performance can be O of n factorial time because of backtracking and stuff like this. I don't know, I've never seen one, thank God. But you really got to be careful about that. And another thing, I did put it up there. They do not support recursion. Regular expressions do not support recursion because they are at the lowest level of this Chomsky hierarchy of parsing. So if you do HTML, I don't know how many of you, by hands, how many of you have seen that famous Stack Overflow answer about parsing HTML with regular expressions? Yeah, isn't it great? Love it. If you want to parse HTML, regular expressions is not the way to do it. Rosie can handle HTML because Rosie is a pattern expression grammar, not a regular expression. And it's a better alternative. I talked to you guys partly because I saw this first at Strange Loop in 2018. Dr. Jennings presented on Rosie, and I loved it immediately. I thought, this is great. This is so much better than regular expressions. But unfortunately, so few people know about this. And I've seen people say, oh, we should build this into Elixir. There were some other Elixir developers there in 2018. A lot of enthusiasm, we never did it. So I wish, if nothing else, I hope you look at Rosie when you go home and say, hey, this is really good. This is nice. Give us some love. But anyway, be that as it may. Rosie has a lot of nice features. One, you can name your expressions. You can do that in regular expressions too, but again, most people don't bother. It's kind of like, I talk to OOP programmers and they say, well, immutability, I can just put a constant on this. Yeah, but do you? Most don't. Slap a constant everywhere. Yeah, well, when you do it, let me know. Rosie lets you name your patterns. You can use those name patterns in other expressions as well. It also has built-in unit testing, which to me is, if I didn't like anything else about Rosie, that all by itself would recommend it really strongly to me. Matter of fact, you see how there I've got that at the very end there, it's got a period there? Initially I didn't have that. And then I put in that test.submodule and it failed. And it's like, wait, hold on, I know that's a valid module name. I guarantee it's a valid module name. And that's what told me I needed to add that period there. So to me, it's almost like test-driven development for regular expressions, and it's great. Okay? So a little further, Rosie allows us to build grammars that can do recursive things. In this case, what I've done is I built a grammar that says, okay, the start of a module looks like this. The hat there is the start of a line for regular, and it supports regular expressions too. Then it says the space star, which means 0 or more spaces. Def module, module name, you notice I can compose that. So if I make sure I get my module name right, then I don't have to worry about this part. Do, and then followed by, again, 0 or more spaces. Now, this is the really interesting part to me. That second line, under the in. Module equal, the tilde is something that he built into Rosie for boundaries, like spaces and stuff like this. Not comment character. Not comment character means it does not start with a hash. It does not start with the pound sign. I defy you to do that in any grep I've ever seen. You can't do that, and it really annoys me. I've never seen a regular expression that does that. There may be, and I don't know. I'm talking to an audience that probably does know. But that alone is terrific. So let me show you a little demonstration of using Rosie. Okay, and first I'll show you the unit testing part. "45 tests, all passing," right? That's great. So again, if I need to modify my expression, I discover, hey, I forgot to allow for so-and-so, I've got those unit tests to back me up and make sure I haven't gone off the rails, and that's terrific. Now, again, you can do that with regular expressions if you want. I just don't ever see anybody doing it, but that doesn't mean it doesn't happen. Okay, so here to show you a little bit of Rosie in action. Tilde, nope. Tilde slash ecto, and it's RPL, grep. Now, I'll tell you in advance, this is going to look kind of like you're going to look at this and say, wow, that's not really nice. It doesn't color it or anything like that. It does have the ability, I'm just putting out plain text. It has the ability to put out JSON and also JSON pretty printed. I'm just not going to bother to show you that. So if you wanted to take the output of this and feed it back into Elixir, you could take that JSON and feed it right back into Elixir. Okay? I know I had the command right. Oh, duh. Sorry. See, this is what you get for live coding. There we go. Okay, and just to make it a little nicer, I fed it into the last pager. Let me just go forward a little bit. I know I'm going by it fast, but one thing I want you to notice, at no point do any of those def modules have a pound sign in front of them. And I know there are some in there that have a pound sign because I saw them earlier. That is totally out of there. I'll be honest, I hadn't got as far as I would have liked on the Rosie Pattern Language stuff I was doing with Elixir. To me, we could almost start using Rosie as a way of building almost like a BNF form of, what should Elixir look like? What's legal constructs in Elixir and what's not legal constructs in Elixir? I could also see this being used for like a linter tool. One of the things that occurred to me is I sometimes forget and leave an iex.pry when I'm pushing code up. And I shouldn't do that. That's a big, big no-no. So to have Rosie go through and say, here's iex.pry, then I would know, oh, shoot, I got to take this out, and it would help me to prevent certain errors from happening. And that would be easily doable with Rosie. Okay. Sorry, I'm just trying to see how I'm doing on time. And I didn't start my timer, so doesn't help anything. All right. All right, so these are some resources for you. Programmers greps, ACK is the one I use because I'm accustomed to it. ACK is really pretty cool because on their page, they have links to other programmer greps, which I thought that's pretty decent of them to say, hey, and by the way, you might try this, you might try this. AG is called the Silver Searcher, supposed to be a little faster than grep, or ACK, I'm sorry. I'm not sure about that. Honestly, to me, ACK has always been fast enough for what I need. RIP grep is Rust programmer grep. If you like Rust, the source code's there for you. That's the home page of the Rosie Pattern Language. I didn't really get into Rosie's original use case was she was at IBM and they were searching tons of logs. And they started trying to do regular expressions and ran into the problems that everyone runs into with regular expressions. They're hard to write, they're hard to read, et cetera, et cetera. So they started coming up with Rosie to fix this. That's really more Rosie's domain than programming languages. It's like searching through log files. I did something a few years ago where I was just trying to demonstrate to somebody and looking for phone numbers. And again, I searched a lot of regular expressions for phone numbers. No one had in their phone number regular expression 000 is not a valid area code. It isn't. 999 is not a valid area code. It isn't. With Rosie, I could make such that it would skip those. So it wouldn't even show them in the first place. That was great. My name, as I said, is Onorio Catenacci. If you want to get a hold of me on Twitter, it's Old Dutch Cap. If you want to email me, it's catenacci.eee.org. That is the code I used in the talk. Like I said, there's not a lot there. A couple shell scripts. And my Elixir.rpl, which is Rosie Pattern Language, as well as these slides will be up there. So if you want to look at them later. I think that's pretty much it.